Hello, everyone. Thank you for joining today. We're going to talk about the Continuline barrier wall product line by IAC Acoustics. My name is Andrew Polte. I'm the NVH and Test Facility Sales Manager with IAC Acoustics. Today, I want to give a brief overview of our barrier wall product line, specifically focused on the Continuline brand, and I can talk about the difference between our barrier walls, our typical barrier walls, and the Continuline line of barrier wall systems. We'll go over some case studies, some photos, and talk about different applications, and talk a little bit about the engineering of each of the barrier wall systems, what goes into the design, what sort of options are available for our products, and installation and different types of features and functions that the barrier wall systems best support. IAC Acoustics is part of the Catalyst Acoustics Group. Catalyst Acoustics Group has a huge noise control product line among all of the different companies. IAC Acoustics was started in 1949 by Martin Hirschhorn in the Bronx in New York City. We spent several decades there before moving to our facility currently in the Chicago area, where our manufacturing and offices are. It's a nice centralized location in the United States for quick and easy delivery and freight to a lot of the, most of the area in the country. Our sales team on the industrial side includes Ted Marquis. He's our industrial sales manager. Myself, again, I'm the NVH and Test Facility Sales Manager. Darren Riley is our HVAC product sales manager, who specializes in HVAC silencing systems, louvers, and silencers. And then Kalina Winter is our estimator. Most of our Noishield barrier wall systems are for outdoor applications. Typically, they are designed and built to prevent noise from getting into a known location, a receiver, which is typically an office building or a residential area or some space that where there may be a lot of people that don't want to hear transformer noise or HVAC noise or train rail noise all day and all night. So that's the main feature of the Noishield barrier wall systems, is that they are able to contain that noise, keep it out, or reduce it to an acceptable level. Most of the time, these barrier systems have no roof on them. For outdoor applications, there's no roof. They can have anywhere from just one long side. They can have two sides, three, or even four, to be fully surrounded by the whatever equipment or whatever sound requirements are needed. The main feature of a barrier wall is to prevent the direct line of sight for a sound source. On the illustration on the upper left, you can see that the car represents a sound. Maybe it's a freeway or a highway or a side street that's got a lot of traffic and it's producing noise into a house that's unwanted. What we would do in a situation like this is to design a barrier wall, so just a single straight wall that can eliminate that line of sight for the noise. So it will not completely reduce it down to zero, but it will eliminate most of the energy that's transferred to the house. So there's a little bit of energy sound energy that goes through, and some sound that goes up and over and diffracts down to the sound source. But the idea and the intention is that the noise level is significantly reduced, and it puts it at an acceptable level or something that is much less noticeable. You can see from the illustration that a taller barrier is always better. Of course, that may or may not be possible given the constraints of the project. And it's advantageous to have the barrier wall as close to that sound source as possible to allow you to minimize the height required for the barrier wall. And the more indirect that noise source path is, the more sound reduction you'll get. We have several different performance options for our barrier models. On the top table, you can see we have STC 30 up to STC 33 performance. That's the sound transmission class, just tells you how much sound is able to be blocked by the, is reflected back from the barrier wall. And on the bottom table is the NRC, or noise reduction coefficient performance. You can see that actually the overall noise reduction coefficient is fairly similar, around 1 or a little above 1 for all the different models of barrier walls we have. But if you look closely at some of the data in the first column, especially at the 125 hertz octave band, that noise reduction coefficient performance changes quite a bit. So this really illustrates how important it is to understand your noise source, not just an overall noise level, but looking at the frequency content of that noise source is really important to help determine what sort of barrier wall system that you might need. IAC's barriers are roll formed. We create the barrier panels at our factory directly, so we have the ability to manufacture panels all the way up to 20 feet long, and we can paint them. We can paint them in-house actually for systems that are 12 feet long. For any panels bigger than that, we have them electrostatically painted, but we're able to do that. The advantage of having the larger, the wider panels is obviously you don't have to have quite as much structural steel. It can be a much more cost-effective solution as long as we're able to still meet the performance criteria for static deflection, seismic loads, wind loads, that sort of thing. We do have a lot of different applications. There's a variety of barriers that are needed in lots of different environments. The photo here on the upper right screen is a barrier wall that had a customer requirement to have no structural steel on the ground. So this entire barrier wall is actually cantilevered off of the side of a concrete wall structure. So that was a pretty unique application. Most of the time, these walls are supported from the ground, but that just shows some of the capability and interesting requests that we get often for these different types of systems. Most of our wall panels are going to be 5 inches thick. The Continuline wall panel, the Noishield SFS, and the FST. We do have a slimline system that's about half that thickness. It's 2.5 inches thick. So that also is an option if we need to have a light material. Maybe the sound reduction isn't quite as significant, so it's a little less expensive. It's lighter, less structural steel required. These panels are available in steel. When they're in steel, typically they're either powder coated or electrostatically painted. We do have an aluminum option available as well. This is a cross-sectional view of our panels. Typically they're 18 inches or 24 inches tall, horizontally laid down and vertically stacked. One thing to point out on this that is really important in the design, on the perforated side or the left side of the cross-sectional area, you can see that perforation goes halfway through the bottom of the panel. And this is really important because it allows you to wick away moisture and have water from outdoor weather drip away much more easily and cleaner, so you don't have pooling inside the panels, and you can avoid, it really extends the life of the barrier wall, so you significantly reduce the amount of corrosion that's there. And if corrosion is a big problem and this is potentially put into a hazardous environment, again, we can do more resistant materials, aluminum, steel, even stainless steel is an option as well. And there's a wide variety of color options. We have a standard list of options, but then there's also custom options available too. So here's a photo of our Noishield FS panels. You can see that the panels are laid out horizontally stacked, and then there's structural steel I-beams or wide flange steel columns in between. This is a really good option for many applications. It's a fairly clean look. It's again, paint is customizable. The materials are G90 steel or aluminum, and they're paintable as well, so they're very corrosion resistant. In the drawings, you can kind of see the bottom drawing, some of the corner detail, so the I-beams are exposed, and then the joining steel between the two barrier wall panels have I-beams that are exposed as well, and you can kind of see that on the left image. So the Continuline panel system really differentiates itself in that it hides, the design hides all of the structural steel. So you can see on the corner detail here, there's actually a trim piece that covers up that I-beam. So all you see is a large trim piece rather than the structural beam itself. And then for joining steel between the two columns, that I-beam is offset to the interior of the wall, and then there's a notch in the Continuline panels to really hide that that structural steel, so that all you see is a panel with a small seam. And then there's a good image of that of a pretty tall system. The Continuline panel system was actually on the roof of this, and the end user in here really wanted to match their building, so they wanted to have to essentially eliminate that structural steel and put a nice horizontal column stacked there without any exposed steel. Here's a pretty good example of a Continuline panel system that's slanted. So this achieves a couple of things. First of all is aesthetics. It looks a little bit more architecturally appealing rather than having the more boxy shape. But the other thing this does is it really helps contain the noise slightly better by having that angle in there. It's able to reduce the amount of sound that it gets over the walls by containing it slightly better. We have for the aesthetic portion of it, we have slotted end caps, so it really helps hide that the end caps are really well hidden along the rest of the steel. You can, I mean, it's really hard to tell in the image that there's even caps here, but there is a slotted end cap that slides in to the roof channels really well. Again, this is another image of the Continuline panel system. This one has a door in it, so we're able to put in penetrations for doors, any sort of pass-throughs for utilities, electrical, things like that. Any HVAC ventilation fans or HVAC ducting that can go through right through the panels as well. We would prefabricate that at our factory and have those penetrations designed beforehand. This is a little bit more detail of the other side of the barrier panel, so you can see the structural steel in this slotted area towards the top center of the photo. We have some flashing and steel detail that cover that up really nicely. Again, this is on the absorbing side. You can see the front face is very well concealed. Again, the absorbing side, you can actually see the acoustic insulation in there, and you'll see that perforated sheet steel goes underneath as well for to be able to reduce the amount of water that can condense and form in there. It falls out very quickly, very easily. And it's just a photo again of the penetration options there are. So this one has the supply and return ducting through the pass-through, and also even some of the structural steel is passing right through that wall system. So there's a lot of options there. So the scope is really whatever is required for the job. We can supply just the materials for this system. We can also supply the engineering design work, PE, and seismic structural calculations. We can supply installation, essentially a full turnkey system if that's what's necessary. There's a lot of flexibility here. We have the capability to do, we can either provide just the materials or we can do the full turnkey with install and design and everything else. There are a lot of different applications for these barrier walls. Some of the more common ones that I see are these roof-mounted systems, electrical, to cover electrical noise or to reduce noise from HVAC systems, chillers, pumps, any sort of mechanical hydraulic pumps that are roof-mounted and potentially could cause some noise that might bother the neighbors. There's a lot of machinery, heavy equipment, HVAC equipment. There's just a few more examples here. You can see that for a lot of these roof-mounted applications, oftentimes the barriers are installed with a gap between the floor or the ground, the roof ground, and the bottom of the panel, and that's just to keep the panels from sitting in standing water. Oftentimes you could have some puddling, especially on these flat roof systems, and snow as well. So a lot of times they end up raised as much as possible without sacrificing too much acoustic performance, but still being able to reduce the impact from rainwater and other corrosive things to extend the life of these barriers as much as possible. There's just a few more examples. We do lots of highways, a lot of railways and train station systems, especially, and anything close to a residential area or a commercial office space or apartments, things like that. They're very popular in larger cities with a lot of rooftop mounted systems. We do barrier walls for airports as well to keep the jet noise, airplane noise away from the local residents, or to maintain maintain a safe, acceptable noise level for continuous exposure. That's all I had today. Feel free to reach out to me with any questions at apolte@iacacoustics.com. Let me know if you'd like a copy of the presentation, and I appreciate your time. Thank you for attending. Have a good day.